The terrible news is that there is a possibility that Voyager 1 has officially come to an end. In addition, today we are going to discuss the issues of why and what. In analyzing the most major achievements that the mission has achieved over the course of the last few decades, the most likely outcome will be discussed. This is, in fact, the longest mission that NASA has ever undertaken. For a considerable amount of time, this has been going on. Welcome back, space enthusiasts, to another mind-blowing episode of SpaceVerse, where we unravel the mysteries of the cosmos. Today, we're diving into the intriguing story surrounding Voyager 1. From its groundbreaking discoveries to the technical hiccups it's encountered along the way, we'll take a comprehensive look at Voyager 1's incredible journey. Don't forget to like, subscribe, and hit that notification bell to stay updated on all things space. Let's get started. The countdown that is based on NASA indicates that the mission has been going on for a total of 46 years, 5 months, and 22 days at this point. In addition, it is technically still going on. Voyager 2 is a tiny bit older, to be even more specific. Despite the fact that Voyager 1's significantly faster pace has always made it slightly more important. We will speak briefly about this mission as well. It was able to travel through the outer layers of the solar system at a substantially faster pace as a result of this, which allowed it to communicate a great deal of fascinating data for a very long period and provide us with a great deal of new information of the solar system. In any case, before we discuss some of its achievements and the magnificence it possesses, let's briefly go over the worries. To tell you the truth, the launch was one of the first challenges that arose. On September 5, 1977, the launch of Voyager 1 came dangerously close to failing, whilst the launch of Voyager 2 was absolutely fine. After one of the rocket stages had stopped burning, a number of adjustments were performed at the very last minute in order to prevent the rocket from crashing and to bring it into orbit. It was a fortunate turn of events that the engineers were successful, and the remainder of the journey was trouble-free for the subsequent many decades. Considering the fact that it has been observed from Earth on a daily basis since the 1980s, this article is about the way its trajectory appears. It wasn't until it exited the solar system and started coming into contact with a bigger number of cosmic rays that it started experiencing some of the other problems that it had been experiencing. Between August and September of 2012, it had a sudden fall in the amount of solar particles that it was receiving, which enabled us to determine that it had officially reached interstellar space in 2012. During the same time period, however, it also started to receive a significantly increased amount of radiation from sources that were located outside of the solar system. In addition, it did not have any form of protection against cosmic rays, which are known to cause damage to a vast number of components. One possible time for this to have taken place was in 2017, when the Voyager 1 spacecraft experienced the sudden failure of many engines. In spite of the fact that it was not using thrusters, NASA was forced to come up with inventive solutions when it suddenly stopped responding. They finally made the decision to put the secondary thrusters to the test after what looked like another 40 years had passed, and it seemed as though they were successful. Before the thrusters of the probe were triggered for the very first time, it had been flying across interstellar space for a period of 40 years. Nevertheless, the subsequent problems started popping up in the year 2019. The problem was not because of radiation or anything else. Rather, it was because there was not enough power. Turning the probe around and looking at it from this perspective will reveal that it is equipped with a radioisotope thermoelectric generator, RTG, which is a type of thermoelectric generator, for the purpose of providing electricity to the probe. This generator stores plutonium in bows. It was able to dissipate approximately 450 watts of heat rather than electricity when it was operating at its peak performance in the 1970s. In spite of this, his power would decline by around 4 watts on a yearly basis due to the fact that the half-life of this particular type of plutonium is slightly less than 90 years. After 46 years, the loss of authority was readily apparent. In 2019, as a consequence of this, NASA engineers were required to make a sacrifice. They turned off the heaters on Voyager 1 and Voyager 2, which resulted in a temperature drop of 50 degrees Celsius for each and every instrument. Surprisingly, however, they continued to function effectively. Throughout the subsequent 2 years, each and every one of these devices was required to function in temperatures that were exceedingly low. In the year 2022, yet another issue with Voyager 1 was discovered. The telemetry system started behaving improperly, Voyager 2 was utterly unaware of the strange, huge data that was being transmitted by the manner in which the attitude articulation and control system was truly operating. That then was the point at which the problems were officially identified. In spite of the fact that NASA was able to reset it and prevent the errors from appearing, this was more of a stopgap fix than a permanent one. Then, in the beginning of 2023, a different decision needs to be made in order to be able to keep the instruments operational. To accomplish this, the United States would need to either make a change to something within the system or turn off one of the instruments. In addition to this, they made the deliberate choice to experiment with a method that was not traditional. As an alternative to making a sacrifice to one of the scientific equipment, they decided to deactivate a voltage regulator. The developers of the system believed that it would not be a problem and would instead save power in the long run due to the comparatively low total power usage. This is despite the fact that the system's official function is to prevent voltage spikes. For the first time, they put it to the test on Voyager 2, which happily did not experience any problems and had instruments that were fully functional. After that, in the fall of 2023, they carried out the same procedure for Voyager 1. Up until November of 2023, Voyager 1 conducted its data transmissions in the typical manner. However, for some unknown reason, it started returning a string of zeros. Additionally, for a few weeks, we were completely clueless about what was going on. At first glance, it would appear that this is the source of the issues. According to the official terminology, the Voyager computer is referred to as the Flight Data Subsystem, FDS, the gathering of data from a wide variety of scientific and engineering devices, the compilation of that data into a single message, and the transmission of that message back to Earth is its principal duty. In a nutshell, it is an essential component for the purpose of cooperating with NASA. On the other hand, the only messages that are returned are zeros. No matter how many times NASA tried to restart it or return it to its factory settings, nothing worked. Voyager has not yet delivered any data that may be used for any purpose. Approximately 4 months after it was initially deployed, even without physical access, no one is able to figure out how to fix it. The most significant problem is that the individuals who were responsible for its design and manufacture, the probe, are regretfully no longer with us. An additional point to consider is that not a single schematic that is utilized by this probe has been digitized. A few hours were spent searching for any information that might be associated with these computers from the 1980s. However, the only file that IWA is able to find was the one that was indicated in the description. There is no construction blueprints or actual designs to be found. On the other hand, it is comprised of approximately 400 pages of a variety of material, all of which is really fundamental and applies to these older systems. The efforts that have been made to discover, decipher, and identify these documents, many of which are nearly half a century old and were created by engineers who never thought the mission would last this long, have essentially given rise to a new scientific discipline known as spacecraft archaeology. Additionally, even when a solution is discovered, the probe will always take approximately 45 hours to respond. That is the distance that the probe is from the planet Earth. In order for a signal to reach the probe and then return to Earth, it takes a total of 45 hours. As a result, there is currently no way to fix this, and locating the relevant papers has been quite a challenge. Consequently, no one who is still alive is aware of what is contained within, which increases the likelihood that this is the ultimate purpose of the mission after all. The fact that the equipment is still operational does not change the fact that the data that was collected is completely pointless. Hence, there is probably no use in continuing with this research. In a few more months, NASA will very likely make the official statement it has been seeking. In spite of the fact that its official lifetime was planned to conclude in 2025 or later, it might end a little bit early. With that being said, its sister spacecraft, Voyager 2, is still operating and has traveled to each and every planet in our solar system. Everything is functioning as it should. There are no issues, and there is a possibility that there is sufficient electricity to continue operating for a few more years. The operation of this probe might therefore continue until the 2030s or even later. There is a possibility that its power will run out after the year 2030, and by the year 2036, it will be so far away that not even the deep space network will be able to go there. On the other hand, it is possible that we will continue to collect data until the late 2020s, well before that. From what I can tell, the fact that we are still gathering information from it is astonishing enough. It was mentioned in the description that one of the films discussed the recent discovery of a gamma revival that was extremely powerful, as a result of the abundance of data collected by Voyager 2 and Voyager 1. Researchers were able to pinpoint the precise location of the explosion. There is a possibility that we could continue to have faith that they will find a solution until NASA makes the official announcement that Voyager 1 will be terminated. This particular spacecraft astonished the scientific community in the 1970s when it discovered that Jupiter and its moons are distinct from one another in a number of ways. It also obtained magnificent photographs of Jupiter and its moons. In contrast to Jupiter, Saturn's upper atmosphere appears to contain a substantially lower amount of helium. This is one of the contrasts between the two planets. Particularly noteworthy is the fact that it was able to take breathtaking images of Titan, which was its primary objective. These photographs revealed a complicated entity that possessed a dense atmosphere, chemical compounds, and maybe even life. Titan has emerged as one of the most fascinating things in the solar system for a number of reasons, one of which is the fact that we have not yet discovered it. Another factor that contributed to its rise to prominence was the photograph that became famous. It depicted a pale blue dot located approximately 40 astronomical units distant, with the Earth appearing as a minuscule pixel. At that same moment, the majority of people presumably believed that the expedition had come to an end. Nevertheless, this was not the case. Inexorably, the monotony continued to take place. At the beginning of its trip into interstellar space, it experienced termination shock, and it proceeded on by a heliosheath. Numerous scientists working for NASA were overjoyed at the time, since this was information that had never been accessible before. It gave them the opportunity to get knowledge about regions of space that had not been explored before. Over the course of its 46 years of operation, the Voyager spacecraft unquestionably accomplished a great deal, including casting light on the solar system in ways that were previously inconceivable. What are the next steps that will be taken with the probe now that the mission has been completed? Does it appear that there will be a collision? Will there come a time when it simply disappears? My guess is that it will proceed with its trip through the galaxy. Instead of going close to any star, it will simply continue on its course without drawing any attention to itself. We are aware that it will reach Giza 445 in the next 40,000 years, and then another star at a distance of approximately 1 light-year in the next 300,000 years. This is despite the fact that our knowledge of its course is limited to the next million years. On the other hand, it will continue to be in a state of inactivity for the subsequent millions of years. Because the possibility of any collisions is so extremely minimal, it is highly likely that it will simply continue to move silently till the end of time. This is primarily due to the fact that it is completely silent. Now, it is reasonable to assume that someone will make an effort to find it and retrieve it if humanity grows to the point where we are able to travel exceedingly swiftly across the entirety of the galaxy. Nevertheless, in the case that such an occurrence does not take place, the probe will proceed with its uninterrupted voyage around the galactic center. This is a pattern that is shared by a large number of other probes, such as the Pioneer probes. No matter what the circumstances are, the fact that these probes are already functioning is already quite impressive, considering that this is effectively the longest-running project that NASA has ever undertaken. The event will take place either when Voyager 2 makes a great discovery or when NASA repairs Voyager 1. A heartfelt thank you for being here with us today as we come to the end of our journey at SpaceVerse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.